Watch this. One press, cylinder it out. One press, cylinder in. Dead simple, right? But here's the thing. Most people who wire up the pneumatic circuit have absolutely no idea what's happening inside the valve when they push that button. And if you don't understand this, you cannot design a pneumatic circuit, full stop. This is a 5-2 directional control valve, and at the end of the video, you'll know exactly what's going on inside it and why it's the most important component in the entire TP101 kit. If you just landed on this video and you're new to pneumatics, I recommend going back and watching video 1 first. Links in the description. We covered what pneumatics actually is, toured the TP101 kit components, and built a simple direct acting circuit. The video picks up right where we left off, so if you're ready, let's go kick some ass. A directional control valve, or DVC, does exactly what the name says. It controls the direction of airflow through the circuit. Think of it as a set of railway points. The train, that's your compressed air. Go one or two ways. In position 1, the train will go down that track. Position 2, the train will go down that track. With this, what happens with this is, in position 1, the air extends the cylinder behind us, or in position 2, the air retracts the cylinder behind us. That's the fundamental concept, but the reason people get confused is because of notation. The way they describe these valves, 5-2, 4-2, and a 3-2, sounds like jargon, so let's break that down properly. So when we look at this, these are the 5 ports. So you see 1, 2, 3, 4, 5, and then we have the red box as a position and the green box as a position. Position 1, position 2. Right then, there are 5 ports, so let's name them, because every single one of these old boys has a job to do. So port number 1, that one in the middle there, that blue one there, is where the compressed air comes from, okay, from the FRL or the FLR, whichever way you call it. Ports 2 and 4, they're the working ports. These connect to the activator, the cylinder that you see just behind my shoulder here. Port 2 goes on one side and port 4 goes on the other side. Simple as that. One, so as you can see through here, port 4 is on this side, port 2 is on that side. 3 and 5 that you see here are just exhaust ports. So when the air comes out of the cylinder, it's going to go somewhere, so it will come out of these ports there. Now, if it was hydraulic, that would be returning to the tank. So when the valve's in position 1, supply comes into port 1 and goes straight through to port 2 to extend the cylinder. When it's the air that's on the other side of the cylinder has to come out, so that will come out, but go into port 4 and out of port 5 into the atmosphere. So when it's in position 2, the air goes into port 1, as it normally does, and it goes into port 4, which then retracts the cylinder. The air that's on the cap end of this cylinder has to come out somewhere, so it returns back through port 2 and out of exhaust number 3. Beautiful stuff. So you can basically see that it's directing the air, the same air, from one side of the valve to the other side, and that's what all the directional control valve does, the DCV. Now here's a bit that most videos skip over. What's actually inside this old boy? Inside the 5-2 valve, there's a component called a spool. Basically a machined metal shaft which has 2 undercuts. Depending on the position of the undercuts is which way the air flows through here. Now I'm going to show you that on a drawing. See direction of the flow as the valve changes position. It's simple mechanically, but because it's all happening inside this sealed body, people assume something more complicated going on here. There isn't really. It's just a block, 3 holes at the bottom, 2 at the top. There's a bit of slides in and out of the side. That's all it is. The reason this matters, especially if you're going through your BTEC, is one of the questions they love asking you, is to trace the airflow through the circuit. If you understand the spool, you can then answer the questions confidently without guessing. Hopefully that makes some sense to you. Right, let's look at the symbol, because this is what shows up in your drawings and your assignment papers. The 5-2 symbol shows 2 boxes side by side. Each box represents one position of the valve. So we have the black one, position 1. We have the green outline as position 2. In each box you've got arrows. And the block lines, the T shapes that you see there, show where airflow is blocked. The lines coming out of the symbol are your ports. Port numbering follows ISO standard. 1 is supply, 2 and 4 are actual working ports, where 3 and 5 are exhaust. And then on the side of the valve, there's got some additional symbols. So directly on the side of the box, it could be one of these, which is a push button. It could be this that represents a spring. It could be this one, which represents a pilot signal. Or it could be this little box with a diagonal line on it that represents a solenoid. So that's electrically controlled, pneumatically controlled, a physical and a physical control, as you see there. So when you look at a circuit diagram and it includes this symbol, you should immediately know that it has two positions, 5 ports, and it could be operated by push button, spring, pilot, or a solenoid that you see down there. Easy when you know how. Okay, let's bring this to life on the TP101 kit. So we need 2 push button 3-2 valves sprung return. So you'll now start to see that there is a zoom in on that one. This is a push button. So that represents that symbol there. That's the push button there. And sprung return. So that's what that little bit there is. And the valve itself is a 3-2. So 3 ports and 2 positions. So you see there. There's the 3 ports there and there. So 1 is at the bottom, 2 is at the top, 3 is at the bottom. So your odds are at the bottom, evens at the top there. Now you're going to need 2 of those. You're then going to need the 5-2 valve, which is that one there. You can see, you can just about see the symbol at the back here. Now this one's pilot controlled, which you see the two triangles. Okay, so it's air operated in this. They go and hit these 2 end ports here. That's your pilots. But your 5-2, you've got your 5 ports here, and there's 2 positions. You can see there's 1 square there, 1 square there. This is what we want to operate. So we have a double acting cylinder, air to extend, and air to retract on those. So let's build this circuit. The first thing I'm going to do is connect the ports. I'm going to connect port 2 to the cap end of the cylinder. I'm going to connect port 4 to the rod end of the cylinder. Okay, so hopefully they're there. I now need some air to go into the 5-2 valve. So I'm going to come straight off the manifold. As you can see here, straight off the manifold there, straight into port 1, which you see here. Oh, without, I'll put the right hose on there. So we now have a direct line straight into there. I also need, in my push buttons in port 1, air as well. So that goes into that one there. That's going to go over to port 1 on this push button. And we're going to use another one of these, and that's going to go into port 1 there. So the only thing left to do is to connect our push buttons, port number 2, which is going to operate this side of the 5-2 control valve, and then this one over here is port number 2, which is going to operate this port, this pilot port of the control valve. Now, just want to show you that if you are messing around with pneumatics, please wear glasses, because that is a hose. I'm just going to leave that loose. I'm going to turn that on. And this is how dangerous these are. I'll flax around. I'll get hold of that. So I'm not going to get more flax around. You don't want that smacking yourself in the eyes. Just make sure you're wearing a safety. Do not put air lines on your skin, because you'll push an air bubble into your bloodstream. That is not good. Divers suffer a condition called a bends, which is not very good. So safety first. Make sure all the hoses are connected. They're not going to fly off. You are wearing your safety glasses, so when you do turn this on, you don't have any of these hoses flapping around. Okay. Now, as I turn the air on, as you see up there, air is coming into this from the manifold into port number 1 and directly into port number 4, which is keeping the cylinder closed. No air is going from port 1 to port 2. If it was, it would open. So when I press this push button, air will go through port number 1 into port number 2 and then straight into this bit here. Extend. I want to retract it. I need to operate the spool again in the 5-2 valve that you see there. When I press that, that's going to shift the spool backwards, allow air to run back from port number 1 through port 4 and then into the cap end, thus closing the cylinder. Every time you see a cylinder moving in a pneumatic system, a robot arm, a production line clamp, a vehicle door, this is what's happening. The spool is sliding backwards and forwards inside this body, redirecting the air from one side to the other. From one side to the other. Air cylinder open, cylinder closed. Quick pause here for the BTEC students, because there are two things that come up in your assignment papers that catch people out every time. Number one is port numbering. Your tutor loves asking you to label a 5-2 symbol and identify which port connects to which part of the circuit. Just remember, 1 is supply, 2 and 4 are the working ones, and then 3 and 5 are the exhaust. You can run out of fingers then. Odd numbers, supply and exhaust. Even numbers go to the actuator. Number 2, describing the valve operation in words. You often get a describe or explain question. Use this structure. State the valve position, name which ports are connected, describe what the actuator does as a result. Keep it short, keep it precise. Your tutor is not looking for an essay. Okay, there's going to be a lot of you handing stuff in. If you've got a specific question you're stuck on, drop it in the comments below. I read all of them and I do my best to get back to you. Before I tell you what's coming next, if this series is helping you out, whether you are studying for your BTEC or just trying to get your head around pneumatics, there's a link in the description. Spit it out. There's a link in the description to buy me a coffee. It generally helps me making these videos and investing in better kit for the demos. Totally optional, but massively appreciated. Right, what's next in the series? I think I really need to be talking about the cylinder itself. Okay, this is double acting. We have single acting as we go from there. So, what do the symbols? What do the symbols look like? Blah blah blah. How it looks in a circuit, and then we should be getting close to drawing some simple circuits for the following videos. There. Make sure you're subscribed. Don't miss that one, and then I'll see you in the next one. If you missed video 1, everything starts there. The link's on the end of the screen. Ciao for now. See you in the next one.